Emission-based innovations for smart dairy. Dairy farms can tackle greenhouse gas emissions directly at their main source. Greenhouse gases include carbon dioxide, but also methane and nitrous oxide. Reducing emissions reduces the carbon footprint of the farm directly and immediately. Innovations in this set involve waste management, which is dealing with the feces and urine of the cows in a better way, and use of additives in the cow's diet. The goal of these innovations is to directly reduce on-farm emissions and hence reduce the carbon footprint of the farm. The feces and urine of cattle, together referred to as slurry when it's a liquid, or as manure when it is solid and has been collected along with the winter beds like straw. Slurry is often stored on the field in a big pond-like area, and manure is accumulated either in the sheds or in the field. Both decompose naturally over time, but they emit methane and nitrous oxide, which are two powerful greenhouse gases during the process. By adding certain additives, such as enzymes, which are products of living organisms, or bacteria, to the slurry or manure, farmers can reduce the amount of methane and nitrous oxide produced during the decomposition process. This not only helps to reduce the gas emissions coming from the slurry or manure, but also improves the nutrient content within them. This remaining slurry or manure can then be used as a fertiliser on any crops or grassland the farmer may have, or by neighbouring farmers. It will be more effective nutrient source compared to the slurry or manure that would not have been treated.
We've put on the manure throughout the winter time to improve the bugs and make a more of an anaerobic breakdown of the lignin and straw within the straw yarded system, and make a better lower pH manure that absorbs into the ground quicker and easier.
Feed additives work on the other end of the cow. Cows sometimes eat feed instead of grass. This happens in a grass-based system when there are no grasses available to graze on, like during a summer drought or when it is too cold like in the winter. In some farm systems, cows remain in barns and receive feed all year round. By adding certain ingredients to the feed, such as garlic, some chemical compounds, and certain oils to the cow's diet, farmers can reduce the amount of methane produced during digestion. Cows burp less, and when they do, less methane is released.
Garlic's a natural antimicrobial, so that changes the rumen biota. Then basically it selects for the bacteria in the cow's stomach that don't produce as much methane, and so the cows carry on being able to digest and function normally. It's just they do less belching, or if they do belch, there's less methane in the belch, and so that's better for the planet because there's less global warming.
There are exciting new technologies being trialled on farms in the UK that are able to remove methane from the slurry, producing high quality fertiliser with none of the harmful methane emissions. It's very early, but this technology will offer dairy farmers an exciting new pathway to reduce their carbon footprint.
One of the main advantages of this is that it takes nitrogen from the air and injects it into our slurry, which is in here. As it does that, that nitrogen then is going to become useful to the plants. So we've managed to increase the amount of nitrogen in our slurry that we'll put on the land, so the crops will need less bought-in fertiliser. So it is saving on our fertiliser bill, and it's also saving on producing fertiliser from fossil fuels.
In conclusion, the addition of microbes to farmyard slurry, feed additives and methane capture systems are all important technologies for reducing methane emissions and improving the sustainability of dairy farming.